Hi everyone, thanks for joining today. So as you know, we just get a new release of Fluent Bit, and usually we have trying to stabilize how often we get a new release of Fluent. And the biggest one happens just try to match what the dates of KubeCon, the biggest conference from the Cloud Native Computing Foundation. So the one that happened 2 weeks ago is version 3.2. And this comes with a lot of interesting features around performance, integrations, but also new experimental features such as eBPF support and other things associated that I'm going to show you now. So I'm going to start sharing my screen. I'm assuming that everything is okay. Otherwise, Austin can ping on the internal chat. Okay, so if anybody of you want to get in touch with me, there is my email. And if you sent me an email the last week or the week before, I have been not checking the inbox, but I promise that if you send me some email, I will try to process my backlog this week. And here is FluentBit 3.2. For those who don't know me, this is first time joining this type of session. My name is Eduardo Silva. I'm originally part of the Fluent team. I created FluentBit almost 10 years ago. Today, I'm a software engineer at Chronosphere, and I have been around the CNCF and the Linux Foundation for many, many years. The project is what we call in CNCF, it's in a graduated state. You know that CNCF has different stages for the projects, and for example, sandbox, incubation, and gradation, which each one of them has its own requirements. We are part of FluentD. Now, maybe just a heads up that we're working to have some special change around the projects that might come next year that will move to a Fluent organization instead of the projects that are under Fluent, like FluentD or FluentBit. So we'll share more details around next year. But today we sit as a graduated state. We graduated around 2019, and it has been an exciting journey. And when talking about FluentBit, I always like to share what is the vision of this project and what are the principles that drives every single line that get merged in this project. And I think that despite, of course, solving all the telemetry data problem that exists today or for many years, right, we do it in a way that we care about a lot of performance, high performance, but consuming low resource usage, right? And I always say that, and I say these analogies like you can have two cars running really, really fast, but what really matters is how much gas you need to achieve that speed, right? In Fluent, we aim to reduce the amount of gas needed, the energy needed, but without sacrificing performance, right? And that help us to push our own boundaries to improve and try to provide something that can solve really the problems that exist today with companies, cloud providers, and in many other areas. When you use Fluent, also from a telemetry perspective, from telemetry data, right, we provide something that is vendor neutral. And when I say vendor neutral, it's not just because it's with the CNCF, because being the CNCF is one thing, but the other is that just we care a lot about integrating with other components that likely you have in your stack. For example, typical example, if you have Prometheus environment for metrics and you have also a strategy or using OpenTelemetry, we want Fluent to be able to integrate in a really vendor neutral way. So the moment that in the future you want to connect to another type of technology or replace one of the ones that you already have, Fluent provides you the capabilities to achieve that in a seamlessly way. Okay, and from a broad ecosystem support, we have an extensive plugin ecosystem. So FluentBit is a powerful small core with built-in plugins, but we allow users and developers also to extend the functionality by using scripting languages, Golang, Wasm. Well, FluentBit is written in C language. We don't expect that everybody would write C because not many people like it, and that's fine. But as well, we care about for those who want to extend it and have a better experience in the developers stage. And when we talk about the problem of what we solve, this is always the slide that I have been using this year. Is like We consider that we have many sources of information. This is just based on the logs where you're seeing right now. And also you have destinations, right? When you are working in your company, you care about how can I analyze my data? That's your final goal. Everything else is a thing that you need to solve, right? But when you have sources that also comes in different formats, and if you're running Kubernetes, which is a distributed system, things can get be a little bit complex because developers create applications. Those applications ship messages in different formats, and you want to parse those formats because you want to analyze that on Splunk, on Elastic, or on Postgres. Or also maybe you want to send the data to multiple locations, and that is a really common pattern in really high workloads environments, right? And the problem of how you collect, how do you move this, and also you do pre-processing is the problem that FluentBit solves. And FluentBit, as I said, has been around for almost 10 years. Next year is 10 years. And it has been growing slowly around to solve different use cases, corner cases, and it works from really small embedded Linux system to big services that runs in all the cloud providers. For example, Google, Microsoft, Oracle, and Amazon, all of them relies on FluentBit. Where do you deploy this? FluentBit can be called an agent, but also an aggregator. Usually you sit FluentBit where you're running your system in a VM, in a container, in bare metal machine, or in a Raspberry Pi. It doesn't matter. The thing is that it's able to collect all the information from your application, from logs, or also scrape metrics from Prometheus or any other type of source of information. Even if you have, for example, a firewall sending telemetry data over a UDP channel in syslog format, FluentBit can be able to receive that information, process it, and package it, and connect it to the right destination. And when deploying this as a pattern, and as I said some minutes ago, you can just send data directly to one destination, and there are patterns where you said, I would like to send this information to two places, right? And the common use case for this is like you have backends who are more specialized than others for certain operations. For example, if you're using Splunk, maybe you like the real-time query stuff or do analysis, right? But maybe you don't want to send all your data to Splunk because also you're not going to query all that information, just a fraction of it, and you might end up paying a ton of money, right? So the approach that many companies does is like they send to Splunk. If they have a record for example, with 100 keys, they just send a copy of that record with 2, 3 keys, which are the important ones for the queries. And everything else are sent to a cheaper destination. For example, Amazon S3. Okay. And when connecting systems, it's not just sending data from the edge directly to the destination. A common pattern of when deploying FluentBit is what we call an aggregator, where you sit FluentBit in the middle and you have other agents sending information, or you have the same aggregator pulling information from other services. Example will be scraping Prometheus endpoints, or you have a FluentBit on the edge sending data to this aggregator, or you have an application instrumented with OTel. It could be logs, metrics, and traces, and FluentBit is receiving that information and routing that information out to the desired destination. And one of the things that I just mentioned is like what really matters for us is be able to interoperate with other systems, right? I think that this is really this concept is really important because when you're going to production or you're planning a new strategy for your observability platform, hey, you want something that can be a plug and play and works with everybody. Okay, it could be the USB-C, right? For observability, right? Now that all the phones supports USB-C, you don't have many cables, right? You don't need adapters. You pretty much have what you need, and this is the experience that we are able to provide with Fluent. And now let's talk about the main topic. I just give you an intro. What's new in 3.2? We really performance freaks. I would say that majority of maintainers and developers who contribute love performance stuff. And we're always trying to push our boundaries, right, on how we can make it better, how we can process the things in a better way, right? Also, from an extensibility perspective, FluentBit used to support a classic configuration mode, which was our own specific format that we have since day zero. But in the today's world, everybody, I don't know if they love it, but everybody uses YAML, right? And we found that there was some friction when people trying to use FluentBit because it was like, oh, now I need to learn this other stuff. Now we fully support YAML. I'm going to introduce Blob binary files, the enhancement OpenTelemetry support that we ship with this version, and two new experimental features, which is one, the eBPF input plugin, and the other is how do we support the new signal of profiles, which is in a very development stage since we're following the OTel profile schema. Okay, so let's talk about JSON encoding. You might be familiar with JSON encoding. Familiar from a perspective of when you see JSON, you might notice that if you have a quotation mark, that quotation mark is not just a quotation mark, it's like a backslash and the quotation mark, right? This is the way that we encode special characters in JSON. And when I say I refer to the world because JSON is a specification and everybody who likes to use JSON needs to be able to use needs to be able to implement this type of encodings. Maybe your API, your SDK, everything is done behind the scenes, but we need something. We have something really special here around, especially not in a very happy way, in which everything needs to be encoded, and sometimes encoding is more expensive in computing, is more expensive in the amount of bytes that are needed. For example, if you have a tab space, which is an ASCII is \t, but has an ASCII code in JSON, that will be 2 bytes because you need to encode the backslash plus the t, right? So you get that it's a bit expensive. When you have this message that is a hi and bye, you just read hi, bye. Oh, good. But you might not notice that this is 6 bytes. It's a hi, a break line, and bye. Okay? And this is normal. This is not JSON. This is just normal. And this backslash n, if you want to convert this message to JSON, it needs to be encoded. Otherwise, it won't work. It won't work by the consumer of this message, right? And the way to encode it, if we use our table that we just mentioned, is like, oh, this backslash n needs to be encoded with backslash plus n. So now we just added these extra bytes. I'm skipping the double quote just for sanity here because it's just trying to explain the global context of how JSON encoding works. And this is just the very basic. I'm not including UTF-8, which has other ways to handle those bytes. Now, imagine that we have this text. It says, hello world, this plan is great, and it will generate cool stuff, blah, 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 blah. If you have this message, right, and you start reading from the HELL, and you want to encode this as a JSON, the first exercise that you need to do is like to identify what are the characters that you need to escape or encode, right? So if you use your AI mind with this, you will find that, hey, I'm able to recognize that, oh, we have a quotation marks here and a backslash n because we have been doing this for many, many years and you can capture this really quickly. However, for a computer, it doesn't work like that, right? You need to tell it how to find these characters. And the very basic way how it's implemented on majority of not languages, but libraries or packages is like go byte by byte, trying to check, is this byte a character that needs to be escaped? Yes or no. If it's no, I'm going to copy. If it's a yes, I need to create the encoded version and append that to the buffer. However, if you think that you need to go through this for every single character, it takes time, it takes CPU. Maybe this will be really fast, you will notice, but if you have a telemetry agent or a telemetry solution that is processing 100,000 messages per second, and you need JSON encoding on each one of them because you're sending to a destination that needs JSON, your CPU will go high because you're doing an operation that is really, really expensive per character, and that is not that good. However, we have a good solution. We got, I don't know if you're familiar with SIMD, but SIMD stands for a single instruction, multiple data. It's an approach where with a single CPU instruction, you can process multiple data points. That means like I can query one character, for example, inside a byte of 16 bytes without doing 16 operations and just one. And we were thinking like, hey, what if FluentBit can speed up the search of characters that needs to be escaped by checking 16 bytes at one time instead of one by one? Let's see the exercise. Okay, so you have identified what you need to encode or escape. Okay, when you operate with SIMD, and there are different versions per CPU architectures, right? There's SSE2, there is AVX, there is a Neon, the version for ARM and Mac, and others. So every architecture will have its own implementation, but the way that we did it in FluentBit, we took the most older version of SIMD implementation that works at 16 bytes, right? Search. And how it works. If you have this message, it has not been processed yet, but you know where you need to try to look for these characters. It works in this way. I'm going to look for the first 16 characters. And the first question for you is, do we have any character in this buffer? With this buffer, I mean the 16 bytes buffer, which is in green, that needs to be escaped? Yes or no? No. Everything is a normal ASCII character. And what that means is just one copy, one operation. I just copy the 16 bytes right away. I didn't copy one by one, just copy 16. And then we continue processing the buffer in rounds of 16 bytes. The next one, do we have a character that needs to be escaped? Yes. In position 0, we got a quotation mark, right? It means like exists. There's something that needs to be escaped. So on that way, what we do is like, okay, now we do the manual process of checking every single character that needs to be escaped, right? And that's fine. It's 16 operations plus 2 operations to copy and encode this byte. And we continue. The same as the first part. Do we have anything on this range that needs to be escaped? No. Everything looks fine. It's an ND space IT W. There's nothing. So we just do one operation and we just copy the 16 bytes. And we repeat this exercise with all the remaining part of the buffer. In the next one, yes. In the next one, we got one character that needs to be escaped. In the next one, there's also a character that needs to be escaped. So we're doing a very conservative test here where, yeah, there are characters that need to be escaped until it ends. In total, if we were not going to implement SIMD, like the old mechanism, we had to do like 90 operations as a minimum, right? But with SIMD, we got that down to 71. Yeah, it's a good improvement, but this is very conservative. Actually, it will depend of your workload, right? How many encoded characters you have. So if you don't have within the range of 16 bytes, we want to optimize that. And you will notice that some people have been doing tests about this implementation and they got, oh, my CPU is 30% down now, it's better. And things like that start to happen. Now, another thing that we ship on this version is the full support for YAML. As I said some minutes ago, we used to support a classic configuration mode, but YAML was implemented in FluentBit already at the same time, that classic mode, but we missed some other implementation for specific sections of the configuration like plugins. I'm going to list, I will not trust my memory, in plugins, filters, and others. Now, let's think about the classic configuration mode. Maybe you have seen this, like a FluentBit.conf file that have a service section. You have multiple inputs, one of them multiple filters and multiple outputs. When configurations start to grow, it's hard to read. And actually, that happens also in YAML. The difference is that in YAML, you likely will have more tools. The difference, like your editor, like Visual Code or anything, will have more tools to play with YAML configuration. And in classic mode, for example, parsers, we were designed to have them in a separate file because of simplicity, right? But at that moment when we designed this, Kubernetes was not mainstream. Not everybody wanted to have a huge configuration file that was assembled by tools. So we separate this. We define a parsers in a different file. And we reference, for example, from a classic configuration standpoint, where, for example, tail, where we have the red arrow, the parser docker points to a parser that was defined in another file. And that file was defined here in the service, in the green box. Okay, this is classic configuration mode. And with new YAML, this gets simplified a little bit, where we continue having the service. Of course, the definition is in YAML format. And pipelines, of course, now are a pipeline. So everything, inputs, filters, and outputs are defined inside pipeline. Everything that I'm showing here is just a single file. You still can link the data to a different files if you want, because you're used to, that's fine. However, we have provided a new mechanism where parsers and multi-line parsers can be inside the same file, and there won't be any problem around referencing the parsers like we were doing before. And yeah, so this is the new YAML configuration mode. The documentation has been updated, and our goal is to encourage everybody to move to YAML. We are not deprecating yet the classic configuration mode, but however, it's important to understand that the schemas that are available in classic, they are things that we cannot configure in classic mode, but are only available on YAML. So, short story, if you're using YAML, you will be fine and you will have all the features. Also, as I was saying, all these features, I was referring to processors. And processors are a way to process the data, right? Right away once the input plugin generates that data. There's no routing involved, right? But processors are only available on YAML. And you can run filters as processors, that's fine. Right? But this is the thing that I wanted to highlight regarding this configuration mode. Another thing that we just launched in Fluent Bit 3.2 is the support of Blob, binary files. And you might guess, okay, what is this? You usually use Fluent Bit to stream logs, metrics, or traces, right? This is a streaming fashion. The data comes in, every single record has its own timestamp, and it works perfect. We might not send the data in order to the backends, but that doesn't matter because the backends know how to sort the data if they need to, or how to index the data to provide better queries. But in Blob, what is Blob? And the Blob aims to transfer big files in a reliable way. And when I say big files, it could be a gigabyte file, but in a way that we are skipping buffering, we are doing a zero copy strategy. Right? That means that we use the original file buffer that contains the data as the buffer for FluentBit. And we are able to take this big file, do a logical split of parts, and assemble them back in order when this is sent out to the destination. Imagine that you have PDF files, or you have, for example, a video, and those videos, yeah, you cannot switch the order of the parts of a video file, right? You will get a movie that is corrupted, you won't be able to play it, right? The decoding won't work. Same as for PDF. Today we support blob files for Azure Blob, and we're going to launch shortly in a few weeks. It's the same support but for Amazon S3. So now you will be able to use FluentBit to send data to S3 and Azure Blob, considering that those are big files, by using the Blob mechanism, which is different than the others that you're used to. When you send logs, metrics, and traces, say, hey, we send the order doesn't matter that much, x 132, 132, the same for the other signals, but here's different. And how this has been implemented. We got a new input plugin that is called Blob. So we didn't get a better name. So what it does basically discovers in a file path like tail, you just give it a path and discover all the files that need to be processed. Right? It registers the information of those files, right, into a local database, and it emits an internal signal that is called a blob signal. When the FluentBit is going to flush the data, it passes the reference to the plugins that are able to handle that blob information. In this case, Azure Blob, which is the output. It receives the signals, it creates an upload strategy into a database file, and it starts uploading the parts. And when it uploads all the parts, it doesn't matter the order, it takes care of reassemble all the parts in order. Well, Azure Blob provides an API for that. We don't need to re-upload anything. We just upload the parts, and then we have a final request to the API endpoint that says, please reassemble this file in this order with this part in this right order. And that's pretty much it. Okay, and how this is useful? Well, we got this quote from our friends from General Motors that is using Fluent Bit in the connected car program with multiple instances of running Fluent Bit in the new vehicle launches. So General Motors, you might know it, is a manufacturer of cars, and many of those cars today are, I don't know if this is the right word, smart cars, right? But autonomous drive, they have tons of cameras, and internally they have computers, right? And they run Linux, they run QNX, and sometimes they run Android, or multiple operating systems. And it's a vehicle that also needs to send telemetry, and FluentBit is a default agent for that purpose. So the Blob implementation has been designed to support the General Motors use case, and of course is open source and available for anybody who wants to use it. The use case, one of the use cases, like, hey, we need to upload the recordings of the vehicle, the videos, right? And those are quite big. And they're using FluentBit for that, so that's really good. The other part is like, I got a lot of questions around OpenTelemetry and FluentBit and OpenTelemetry, and I would like to give an intro also for folks who are new to OTel and how this correlates with FluentBit, because there has been a lot of confusion because there's a lot of information and sometimes the information is not clear enough. So let's do not a quick overview of OTel per se, just OpenTelemetry. OpenTelemetry provides an open source standard for logs, metrics, and traces. Thus it is. It created schemas and said, this is how a log should be composed, a metric and a trace. And the schemas are defined in a way that they have versions, and developers said, okay, I'm going to use OTel, the OTel specification to create my logs. My logs will have these schemas. The same happens for metrics, and the same happens for traces. When you got the schemas, right, data that has been composed in that format, you need to transport that from one place to the other because you want to analyze the data, right? And this is why OTel implements or call what is called the OTLP, the Open Telemetry Protocol, which is pretty much gRPC, right, over HTTP2. This is the channel that they use to move the data from one endpoint to the other. Of course, they have a format, they have a definition, a specific API spec. And when applications needs to generate or want to generate data in OTel, what they can use are the instrumentation or the SDKs library. For example, if you're using Python or Golang, you can import or use the packages that implements OpenTelemetry for your own application, so your application is able to emit the signals, logs, metrics, and traces are signals, right, by using the schemas and using the transport, which is OTLP, to the endpoint that's going to receive this information. And the next question is where FluentBit sits here. FluentBit fully implement the read and write of the schemas of OpenTelemetry. That means it can receive OTLP and can write or send out OTLP. So we support the schemas and we support the transport. So any application or any service or exporter speaking OTLP can be connected to FluentBit, and from FluentBit, you can send that information as OTLP in the outside, or you can send it out as, I don't know, a Google Stack driver if you want. Yeah, it doesn't need to be OTLP in the output. However, we support everything from one point to the from one endpoint to the other. One feature that is really interesting is not just able to read and write, but also to read and process the information before this information is sent to the destination. This is what we call that we're able to collect, transform, enrich, and deliver. For example, if you're running, sometimes you're receiving too many traces, right? And you don't want to all the spans that are being generated by the traces because you know that some of them are useless for your own use case. You just can instruct FluentBit to remove them or stop processing them. And that's it, it will work right away. As I said, FluentBit can listen from OTel messages and can be used to send messages. And the same thing, you can have multiple agents, application instrumented with OTel, and FluentBit is able to aggregate, or it can work as a collector, maybe if you are familiar with that concept, and send that information to OTLP endpoints like services that receive that information. Other features that we have in FluentBit for to deal with OpenTelemetry is like, and when I say with to deal, because majority of the industry have might are thinking about the strategy to move to OTel, while some of them already moved. But when connecting system, you get to the point where not all your applications are going to be instrumented with OTel. It's really expensive in terms of time, right? What you do is maybe the new ones, but for the olders, how do you connect older systems with an OpenTelemetry endpoint where you're going to receive the data? And this is where we provide a special processor that is called OpenTelemetry envelope for logs, and that allows you to take any log information, for example, read by tail or by systemd, and package it as an OTel version of it by using the schema. So the envelope pretty much put the result, the scope, the attributes, and everything. And that allows you to move this information in an OTLP compliant way to different endpoints. And with 3.2, we implemented this as well for metrics. So for example, if we are scraping metrics from Prometheus endpoint, or receiving over remote write, or you're receiving metrics over statsd, and you want to send that to OTel, yes, on OpenTelemetry endpoint, you can use the OpenTelemetry envelope as well. For traces, it's not needed because traces is just OpenTelemetry format. I'm not sure. I don't want to say I don't think. I'm not sure if at some point we're going to implement something to convert non-OTel traces to OTel traces. We don't have the use case yet, but if that is needed, we will provide such a functionality. Now, let's chat about processors. Processors allows you to process the data, right? In a way you can enrich, discard, or modify everything. Today we have 5 processors, and the most used one is content modifier. We have label for metrics. We have a metric selector, and we have also a SQL processor. Okay, so for this, I encourage you to check out the documentation. However, we have a few tests for what are the content modifier, a few demos now at the end of this session. Okay, benchmarks. Everybody likes performance and everybody likes to talk about this topic. We never publish any benchmark around FluentBit. Like we always wanted that others who are validating FluentBit publish benchmarks in terms of performance. How is FluentBit doing? Or if you want to put 5, 6 agents, how do they behave under different but similar scenarios, right? Because you might care about CPU usage, you might care about memory usage, and others. So we ran, for the first time, I think that we ran our own benchmarks, because also we found that some other benchmarks around were not done correctly, or were just trying to put FluentBit in a very bad state. from a marketing perspective. And yeah, so we just did something really simple for these benchmarks when we tried out this new version. Uh, and the benchmark of this version I'm going to show right now, it does not have SIMD enabled. This is just very basic. So what we do is in the test is really simple. Read a file, a really big file, parse the content of that file as JSON, and drop the content. Don't send it anywhere because we want to avoid the performance of to measure network I/O, which is a different scope, right? We're just checking how fast we can read, which is faster, but how much expensive it is to read and process the data as JSON, because you have to read as JSON, you need to encode it internally, and then you need to do some extra steps. And these are the results that we got for CPU usage. So let's get the columns. We got the metric type, we got the median, the 90, 95, and standard deviation. And then we have 4 agents that we took from that most of people are using is either Vector, the OpenTelemetry collector, FluentD, and FluentBit. The median, I would say that is more fair value, right? And 90, 95 maybe what it would be the worst case for each one of them. And in CPU usage, right, we got that the median for processing these big files for, I think, for a couple of minutes, if I remember correctly, it's around 40%. It was a really, really intensive test in terms of the data was being generated. However, Vector was 118, the OpenTelemetry collector is 109, right? So when you're processing data at a very high scale, it's really important to understand uh, how much gas you need to process that, right? And yeah, I think the FluentBit did pretty well. And here's the same version that I have here, but with some bar charts, I think that are easy to read, so you can do some comparison. Note that I have not done any special configuration for none of them. It was just the basics. So I'm sure that each one of them might be able to be tweaked or increase the buffers to read more data or process something. But FluentBit is always very conservative on that, same as FluentD. But however, I noticed that I was surprised to find that FluentD was using less CPU than OTel. But of course, FluentD is just for logs, right? So you can, OTel also does measures and traces. So you cannot replace OTel with FluentD, but you can do it with FluentBit. And the others, this is what you have from standard deviation. It's also FluentBit did it pretty well. From a memory usage perspective, right? In the same test, we got the CPU, now it's the memory. We found that the median for FluentBit compared to the other was like a fraction, right? FluentBit's 25, so it's 7 megabytes. FluentBit's 98. The collector 192, and Vector, well, 300 megabytes. It's insane. So when you're thinking to deploy this technology in, I don't know, a few thousands, few hundreds of machines, this CPU and memory usage really matters, right? Standard deviation, the auto collector did it pretty well for the memory usage. So I think that since reading Golang, I'm not a Golang developer. However, I assume that they try to use a lot of cache to reduce fragmentation when dealing with processing the data. So there's not a lot of releasing the memory, allocating memory, as FluentBit was doing, right? But our goal is not to use 200 megabytes, just to keep it as low as possible, right? Some different use cases, different techniques, and different designs. And same as previously, this is the chart of memory usage of comparing Vector, the OTel collector, FluentD, and FluentBit. So I think that when we started talking about the vision of the project, this is really important for us. Are we in every release, are we keeping with high performance, low CPU, low memory usage, right? Are we keeping being vendor neutral? And I think that after 10 years, the implementation of performance improvements are working perfectly. Okay, so eBPF. Let's talk about eBPF. What is this? This is just for Linux. I know that Windows implementing eBPF now, but I don't know what's the status of that. But with eBPF, you can pretty much, in general, you can program the kernel and extract information from it directly with very, very low overhead. There's a lot of information about eBPF, but for our own use case, what we care about, we can check which processes are being running, the files that have been accessed, the memory allocations that are happening, network connections, signal handling, everything. And this is free experimental because while it was written by Jorge, this is available right now in upstream. Is considered experimental because we still need to learn more about how we can use this great implementation in a better way to add more value to users, right? It's not just, hey, we got the eBPF, okay, but now it's what problems we can solve with this. And we are already discovering some of them, so we expect to have some news in a couple of weeks, but at least the first one allows you to do that. And another experimental feature that we got is profiles. Maybe you are familiar with PayProof, or profiling is a technique. If you have a process that is running and is consuming so much CPU, you want to understand what this program is doing, why it's consuming CPU, which function is using that CPU, so you know what to tackle, what to improve in the next release of your own project. And profiles is something that is not new, has been there for many years, right? However, now there's a global interested need in to have this in a format that is a standard, and the best home for this is OpenTelemetry. So the OTel folks, with many other teams from that works in profile systems, like with PayProof and others, have been working in a new schema to be able to ship those profiles, right, by using an OTel schema, and make sure that also this is compatible with OTLP. Now, how this is useful, I think that we are also working ahead the next standardization, which is really, I'm really excited about this in terms of now you don't need to have more system to do profiling. You just can have one type that speaks the same language and the others, and you can take the best from it. Now, profiles, as you can see here in the title, or in the subtitle, are in development version. So OTel works something like, okay, this is stable and this is under development. Under development, there's a lot of breaking changes over time. Because the schema is changing, it's not stable yet, and one is stable, all the implementations will try to adapt to that one. Now, what we did with Fluent is pretty much, hey, let's start implementing the profile signal from now, so we can learn and also learn what will be the overhead and how we can provide a good user experience for OpenTelemetry practitioners by using Fluent Bit. And now I think it's time to open the terminal. I'm going to quit this mode and move my window here. Oops. There's something. Okay. Something wrong with my keyboard today. Okay. I'm going to increase the font size. Okay, so, okay. I'm in the eBPF profiler demo here. If I show you the configuration that we have for embed for profiles, or maybe let me use Visual Code. I think it will be better for you. Demos. Okay, this is for profiles. As you can see, everything is in YAML. We got the service log level info here. We got the pipeline definition, and the pipeline definition has the OpenTelemetry, the receiver, and what it's doing every time that it's going to receive data from OTLP is going just to print it to the standard output. So FluentBit is going to receive this information and print it. But who's sending the information? There is a project that was donated by Elastic, the company that makes Elasticsearch, that is called eBPF Profiler. So eBPF Profiler is like the first agent that aims to implement the profile signal from OpenTelemetry. And the way to run it is pretty simple. As you can see here, you just disable TLS and you just point where do you want to send the data. In our configuration, I have this disable TLS because certificate things, and this is just a local machine. We don't want to mess with that. So I'm going to just run FluentBit here. And now it just started. It's listening for OTLP on 4317. And in the other side, I'm going to run the eBPF profiler, which in my Linux box is going to get information profiles from the system, and it's going to send it to FluentBit. And FluentBit is going to print the information in the standard output interface. So we just let it run. It takes a couple of seconds to collect the samples. And as you can see in the standard output, now we can see the information that is being generated. All with the location, the profiles. I have no idea how to interpret this or the function that's being called. Yeah, the schema is a bit complex to understand if you read this, but of course you will have tools that allow you to visualize this in a better way. Right? So you have the attribute tables and so on. So today FluentBit is able to receive these profiles, right? And as soon as this get onto stable on the OTel side, hey, this will be ready. The only thing that if you want to start using this with FluentBit today, you need to enable this option, profile support on. Since it's experimental, we don't turn on experimental features by default, but you need to do it manually. Okay, let me drop this one. And also for in eBPF, I will have the configuration here. For the eBPF plugin, which is experimental, we can add the traces for signals, for every signal that's generated, for every malloc allocation, for every port that is being byted. And what it does is to send information to standard output because we want to just verify this here in the live code. And it's pretty straightforward. Oops. Oops, I need permissions. Why not? Okay. Let's do the following. There you go. So right now it's reading all the information by using the internal signal. Sorry, the eBPF plugin is using the on eBPF code to trap the information from the kernel, so we get mirror location, signals that are happening, and so on. Yeah, there's some things that need to be fixed here. For example, around encoding, minor things, but of course these are just experimental features. That was profiles and eBPF. The goal is that at some point you will be able to upload your own eBPF code by using FluentBit. So we want to, and I think there are many projects like Spectre Gadget and others that want to standardize in a way that, hey, we can have one eBPF code that can be loaded by different agents which provide its own value as a FluentBit. And now let's do let's talk about this processing. Okay, we're going to jump into this demo. Oops. Okay. The only relevant code here is this. Processors allows you to modify, enrich, or discard the data in many ways possible. So in order to test and show you how this works, we have a pipeline which have the inputs, which is just one dummy. Dummy, what it does, it generates one message per second, and it's always the same message, right? And it sends information to the standard output. So if we do this, you will see that the data is the same message that I have in the configuration is going to standard output. Now, if you want to look this in a very beautiful way, you can pipe it to JQ, and you will get the JSON message that we were generating. So it becomes easy to read. Okay, We're not doing any processing. This is just, how it works. Now I'm going to enable our first processor. Processor lives inside the input plugin. And we always put the processors section and the processor that will be applied to the logs generated by the input plugin. So, but for example, this is also totally valid because we have processor for metrics, so it will go here. An input plugin can generate data for logs, metrics, and traces, right? But now we're just going to show you logs. We're going to use the content modifier processor, which is a native processor. You can run filters as processor. They're little difference, but what we're going to do here right now is to use the insert action that allows you to insert a new key. It will be called new key, and the value will be called new value. As you can see here, let me stop it. The new key has been added to every single record. Of course, this is a very, very basic, example. And now I'm going to add another processor. Now, processor runs like a chain from top to bottom. The output of the first one is the input of the second one. So what we're going to do is to use the hash action. And the keyword that is called message, we're going to hash it. So for example, it uses null, but let's use something different. Let's put hello. So instead of hello, that value is going to be hash. So here is the message now has a hash. Now, when is this useful? And when you have PII use cases or something that you want to mask. Another feature of content modifier is what we call the extract action. And extract is quite interesting. For example, imagine that you have this HTTP address, okay? And this one, you don't want to have the address, you want to split by components. And the way that it works, extract, is that you define the key that will be processed, and then you define the regular expression pattern that you're going to use to split the content of that message. So this is called also group capture in regex. So we're going to have one key called HTTP protocol, other for the HTTP domain, HTTP path, if it's HTTPS or not, query params, and everything. Let's see how the message now changes when I enable this. I'm going to stop it. Okay, this is the original one. Oops. Let me scroll down. Oops, I just lost it. Okay, let me run it again. There you go. Okay, so you have the original message, the new key that we added, and now we have all these 4 new keys that were generated by the extract pattern, right? As you can see, we have the protocol, the domain, the path, and the query params. We have other here. Yeah, we can convert data types from, for example, if we got a value that is an integer, you want to handle a string, you can do all the conversions. So these are processors, and something to add the difference between processors and filters. Like filters runs in the main thread of Fluent Bit. Now, if I go to the configuration, this input plugin, it's running in the same thread, but we have this feature that is called threaded. Oops. True. That means that this input plugin will run in a separate thread. And of course, many times you want to do that for performance. We introduced this at the beginning of this year. The difference with filters is that if you run processors, you do processing for this input plugin, and this input plugin is threaded. That means that all this processing is going to happen in a separate thread. So if you have multiple CPU cores and you care about performance, yeah, this will give you more scalability. But also here you can apply, you can run the other filters like red, for example, fill the grep, you can append that as a processor. So it's really cool because you have native processor plus also you can run the older ones in this mechanism.